Hi everyone, welcome to video 17-1A. We're going to be talking in this video about how we come up with the equation that creates a circle. So as you can see here, we're going to consider the circle as it says in the Explore, and I'm on page 889 here at the start of this section. It says consider the circle in a coordinate plane that has its center at h comma k, so the point C is h comma k, and has radius r. If we're looking at the diagram that's below, here's our center, so coordinates h comma k and radius r. So part A says let P be any point on the circle, so we're just picking this point right here randomly, and its coordinates are x comma y. What we want to do is we want to create a radius from the center to that point P, and we're going to create a right triangle as well that kind of connects all those different coordinates together. It says create a right triangle by drawing a horizontal line through the center and a vertical line through the point P back down to the x-axis, as you can see. They want to know what are the coordinates of point A. So if we think about where A is right here, well, that would take an x-coordinate that would go as far as x, which is the same distance out as it takes to get to point P, and as far up as k, which is the same distance that it takes to get up to the center. So the coordinates of that point are x comma k. So if we put those coordinates there, x comma k, that's going to help us figure out the remainder of our exploration about the certain lengths of the sides. So let's look at that now. In part B, it says use absolute value, which remember is an expression of distance, to write expressions for the lengths of the legs of triangle CAP. So if we want to figure out what the length of CA is, that's right here, that's going to be the distance between the x coordinates subtracted and then an absolute value. So the two x coordinates are my second x coordinate here and my first x coordinate, or x minus h, all in absolute value. In the same way, PA, which is our vertical segment, is going to be one of the y coordinates subtracted from the other. So y minus k, also in absolute value. Sorry, having some stylus issues here. There we go. Then it says use the Pythagorean theorem to write a relationship among the side lengths of triangle CAP. So of course we know that that's the length of side CA squared plus the length of PA squared, the two legs, remember, squared and added together, are going to be equal to the length of the hypotenuse, which is PC all squared. Now on the next page, on page 890, under our reflect here, it says compare your work with that of other students. You guys don't have each other around you, but if we were going to write an equation for the circle with the center and the radius, we would basically plug the distances that we had in the earlier part of our exploration into where we have the side lengths. So our equation becomes this: x minus h, or that's my horizontal difference between the x coordinates, all squared, plus y minus k, all squared, that's the vertical distance, or the leg PA, all squared, equals the length of the hypotenuse squared, but the hypotenuse's distance is the same as the radius of the circle. So this is where we can go from here. And as you can see, that's summarized as we begin explain 1. This is an equation that you definitely want to commit to memory down here. And it can be used to write the equation of any circle as long as you know the center and the radius. Couple of things that's important to see here. In number 2, it says, why do you need absolute values when you write expressions for the lengths of the legs in step B, but not when you write the relationship among the side lengths in step C? Well, remember, distances are always positive. And so when you square them, whether we started with a negative distance and then we were taking the absolute value of it, of course, to get the positive number for the distance between a positive and a negative value of x perhaps, squared is always positive as well. Part 3 here of our reflect, it says, suppose a circle has a center at the origin. What is the equation of the circle in this case? Well, the center at the origin would of course be 0, 0. And so that would mean that's my h and my k value in this case. So this would be a very simple equation because x minus 0 all squared is really just x squared. And y minus 0 squared is just y squared. So it would be a very simplistic version of that equation we wrote in number 1. Anytime you don't have a parenthesis or a coordinate other than 0, you don't need the parenthesis when you write the equation. So just keep that in mind. That's also helpful as you go into video 17-1b, which is where we're going to talk about, if you're doing the bonus, figuring out the center and the radius from the equation. Really helpful piece of information there too. Okay, so let's move on and actually write the equation using this new knowledge here. Explain 1, it says you can write the equation of a circle given its coordinates and its radius, so that the coordinates of its center, basically. So you can see in example 1, as we talk through here, we've got a center of -2, 5 and a radius of 3. Notice the equation that we came up with in the Explorer is starting right here, the general equation of a circle equation, the general equation of a circle formula, if you will. And what we need to do is plug in the h and the k. So notice it is x minus -2, so that's why we have x plus 2 all squared, and then y minus k, or y minus 5 all squared, and that's going to equal the radius squared, which we know is 3, and so we can simplify that to 9. Let's see if we can do b. If we're going to plug in the center of 4, -1, then we're going to say x minus 4 all squared plus y minus -1. Be careful there. And then that equals the radius, which we were told is the square root of 5 all squared. So this is x minus 4, but it's y plus 1, notice. And then the square root of 5 squared, all simplified, is just, of course, 5. So then that's our final equation. Let's look at the your turns on the next page. This is going to be your homework. Make sure before you come back to class you have written the equation of the circle with the given center and radius, please, for number 5 and number 6. And that concludes your required video for 17-1. As I said, the next video is a possibility for doing a little bit more algebraic work to get to the idea of the equation giving you the center and the radius instead of being given that information to begin with, kind of working backwards from the equation, if you will. We'll see you guys next time.